Hello Algebras, and welcome to your Chapter 1 Lesson 3 notes video for solving equations. So, we have solved equations in the past. We are really going to just be rehashing the same things that you have done previously for solving equations. What we want to make sure we're applying here are the properties of real numbers that we used in Lesson 2 in conjunction with the properties of equality, the addition property of equality and the multiplication property of equality, which are just telling us that whatever we do to one side of the equal sign, we also have to do to the other side of the equal sign. So these are just two more properties that we knew already. We just now have names to describe what's going on with that particular concept. Whatever you do to one side, you got to do to the other. Okay? So, when we are solving our equations, the things that we are trying to do, we are clearing any parentheses that we may have using the distributive property. We are combining any like terms that we may have using the associative property and sometimes the commutative property to switch our order. We are using the addition property of equality as well as the additive inverse to move certain numbers from one side of the equal sign to the other. And finally, to isolate that variable, we use the multiplication inverse as well as the multiplication property of equality. So the multiplicative inverse, the multiplication property of equality together is what finally gets that variable alone, one of that variable. Well, let's dive into examples. One-step equations. Those are the nice, easy, there is just one step to getting x alone, or our variable. So if you look, here is x. We want it all by itself. How is it currently attached? It is having 3 subtract from it. We don't want that 3 there anymore. So let's do the inverse operation. We are going to add 3 and let's do the addition property of equality to both sides of the equal sign. What does that do for me where the negative 3 currently is? Well, as we know, negative 3 plus 3 cancels out to a 0. So there's no more numbers next to my x. So I bring my x down to the next line. I bring my equal sign down to the next line. Then on this side, I have like terms, 2 numbers. 5 plus 3 gives me 8. What that means is if I checked my answer and replaced 8 with where my x was originally and subtracted 3, I better get 5. What's 8 minus 3? 5. And there you have it. One step, the addition property of equality with the additive inverse got me to x all by itself, 1x alone. Over here, the x is attached to the 2 by multiplication. And what's the inverse operation to multiplying? It's dividing. That's right. So we divide by 2, multiplication property of equality, on both sides. Whatever you choose to do to one side of the equal sign, you have to choose to do that same thing to the other. We chose the multiplicative inverse, dividing both sides by 2. The inverse operation to multiplying by 2. And now we're doing it to both sides. 2 divided by 2, which I canceled out to a 1x all by itself, the goal. Now over on the other side, we got 2 numbers that can actually divide. Negative 10 divided by 2, negative 5. If I were to think about this and check my answer by replacing x in the original equation with a negative 5, 2 times negative 5 is indeed negative 10, and this checks out. So notice I'm just also showing you how you can think about what that x value really means. Both answers we got are real numbers. They are, counting number integer, right? So we are getting some basic answers to start. Obviously, that will change as we go through some harder questions. Okay, we started real basic. Now we're going to get into your 2-step equations. There will be 2 steps to isolating x this time. So if we look at number 3, okay, we've got 2x minus 3 equals 45. So this side, we only have a number all by itself. Okay. adding goes first. If I have anything to add or subtract to the other side of the equal sign, that goes first. So I've got this minus 3. The inverse of, or the opposite of, a negative 3 is a positive 3. What do? Add 3 to both sides. So I get that 3 removed from here, and all that's left on this side of the equal sign is my 2x. I bring that down, bring down my equal sign, and 45 plus 3 gives me 48. Okay, is x completely alone? Is there only one x here? No? Then I have to keep going. So now I've got 2 times x. So x is being multiplied by 2. The inverse operation to multiplying by 2 would be dividing by 2. So I divide both sides of the equal sign by 2. 2 divided by 2 cancels out to a 1x. There you are. The x is all by itself. Bring down your equal sign. Now we perform that operation over here. 48 divided by 2, 24. Okay, this time if you're checking and you think about what that looks like, it's 2 times 24 minus 3 should give me 45. Well, 2 times 24 is 48. That's a number that sounds familiar. And 48 minus 3 gives me 45. And this is how I check my answer to make sure I'm correct. On number 4. Do this so we can just see number 4. So again, we've got x over 3 minus 2 equals 9. So we just have a number on this side. So that means we have to deal with the side that has both variables and numbers. Is there something that is added, subtracted to both sides? That's where we start. So the inverse of a negative 2, a positive 2, I add that 2 to both sides of the equal sign. Negative 2 plus 2 cancels out to a 0. That means only x over 3 is left on this side. Yes, it's a fraction. Do not panic. Over here, 9 plus 2 gives me 11. Okay, so now if I want x all by itself, I perform the inverse operation. Well, remember, a fraction is just a division problem. So I'm dividing by 3 right now. What is the inverse of dividing by 3? It's multiplying by 3. So if I have this value in the denominator, I multiply both sides by that value. 3 divided by 3 cancels out to a 1x, which is the goal of getting. And then we bring down the equal sign and we perform the operation over here as well. 11 times 3, 33. So how to check if x is in this fraction right here? So checking is still the same process where whatever you got for your answer for x replaces x in the original equation. So you have 33 divided by 3 minus 2 should give you an answer of 9. Well, what's 33 divided by 3? It's 11. 11 minus 2, that's 9. And there again is a check. So we're making sure we got those right answers. Okay, now finally, variables on both sides, right? So far, we've only had numbers on one side of the equal sign, just regular old numbers. Now we're sharing variables on both sides. Now, when that's the case, look for, are there variables and numbers on both sides? So in the case of number 5, this side of the equal sign has only variables. So that means the easiest path is to move these variables and leave this number. Variables are just letters in place of numbers we don't know the value of yet, which means that they have the same properties of all real numbers, which also means that you just perform the opposite operations or the inverse operations of these as well. What's the opposite of a positive 5x? It's a negative 5x. We subtract that 5x from both sides of the equal sign. 5x's minus 5x's leaves me with 0x's on the right-hand side of the equal sign, but this sign is still attached to the 28, so bring down a negative 28 to the next line. Over here, these are like terms, so we combine them. 3x's minus 5x's gives me negative 2 x's. Okay, how is the negative 2 attached to the x? All the x's are together on one side of the equal sign. All the numbers are together on the other side of the equal sign. Inverse operations. The inverse of multiplying by negative 2 is to divide by negative 2. So I divide both sides of the equal sign by negative 2. Negative 2 divided by itself cancels out to a 1x, which is, of course, my goal. Bring down that equal sign. Over here, negative 28 divided by negative 2 is a positive 14. And there we have our answer. 1x by itself is equal to 14. When this is the case and you've got variables on both sides and you want to perform a check, it just means that everywhere there is an x, we place that value we just found x to be. So I'm replacing x with a 14 in both spots. Now let's say that you're not great at, in your head, multiplication by 3, by 5, whatever the case may be. Feel free to use that graphing calculator to multiply 3 times 14, giving us 42. Okay, so you do not have to worry about things like that in your head. Now, 5 times 14, that value you've plugged in for x, giving me that 70. And now, check to make sure anything else simplifies. 70 minus 28, right? And when you're using that graphing calculator, you can now just press the minus sign. It uses the previous answer, subtracting whatever value you plug in this time, and you do get that 42 equals 42. Okay. Number 6. No panicking about our decimals either. But what I want you to notice is you've got variables on both sides of the equal sign. You've got numbers on both sides of the equal sign. So that means pick one side for variables, pick one side for numbers, and it does not matter which, because again, it's an equal sign. That means that we've got balance on both sides. So I'm going to move my numbers over here to the right. I'm going to move my variables to the left just out of a habit. The inverse of a negative 12 is a positive 12, and that's where I'm going to go with this, is I'm going to add 12 to both sides of the equal sign. Canceling out that negative 12, it's now over here, and I get a positive 20 here. Now remember, I'm on the other side of the equal sign. I need, if all my numbers are now here, I need all my variables to be on the left. So this variable has to move here. The inverse of a positive 0.4x is a negative 0.4x. And that's what I subtract here to cancel out to nothing. So notice I'm not going to bring anything down to this next line. There are no more x's here. Those x's got moved by the inverse operation over to the left-hand side. So again, they are one place behind the decimal. This should be okay, but in case it's not, 0.3 minus 0.4 is a negative 0.1. So negative 0.1x on this side. To get x alone, you are currently multiplying by negative 0.1. Divide by negative 0.1. So all of that completely cancels itself out. We do that to both sides. So negative 0.1, right? And so if you need any help on that one, 20 divided by negative 0.1 is negative 200. Just think about those, the decimal place, right? Dividing by it, so we're moving another place over, okay? Let's look at our distributive properties last. What if we have a number in front of our parentheses with no sign in between? That's where we give by multiplication to everything inside the parentheses. So 3 times x is 3x. 3 times negative 9 is negative 27. Bring down the equal sign and the 30 on the left that we didn't even do anything with yet. Now think back to what we did with variables on both sides right here. Well, we said, oh, well, we've got all of our x's over here already, so let's move the other ones to be with that, right? You've only got numbers on this side already. The easiest path would be to add 27 to both sides. So the easiest path would be moving that number. Moving that number by inverse operation. Okay? So 30 plus 27, sorry, that one canceled out. We get 57 equals 3x, which is the only thing left on the right-hand side. Now, how is the x attached to the 3? By multiplication. The inverse of multiplying, divide both sides by 3. So it is the same stuff over and over and over, right? Like it is the same thing over and over and over. What we want to do here, bring down that 1x that's left over, 57 divided by 3. Some quick division skills to try over. 3 goes into 5 one time. How many are left over? 2. So now it's 27, and 3 goes into 27 9 times. We saw that right up there, right? So you get 19 equals x, which, by the way, because it's an equal sign, is the same as x equals 19. So it makes you feel more comfortable to have the x's on the left, feel free. One last one, and then we're done. Here, in front of the parentheses, is a hidden -1. This negative and this 1 are what we distribute. So be careful. Be careful. If there's a negative in front of those parentheses, it's actually a -1 that's there. It means that that negative has to be distributed by both things inside the parentheses. So we bring down this x we haven't touched yet. -1 times 12 is a -12. -1 times -x, that's a positive x. Bring down your equal sign and your 28. Do you have two like terms on the same side of the equal sign? Yes, on the left-hand side, you've got an x plus an x. So those add up to 2x minus 12 equaling 28. Okay, all the way back up to that first two-step equation we solved. Add that 12 to both sides of the equal sign. Bring down your 2x. Bring down your equals. You get 40 when you combine 28 and 12. Now, the opposite of multiplying by 2, dividing both sides by 2. So we divide both sides by 2. And we get x equals 20. And there we have it. All right, my fine algebra friends, you now apply this to your 1-3 homework number 1. Use these examples we just completed to help you. Go back through, watch me do any of those that you need again. Maybe go back through and look at those checks one more time so you know how to do that. Good luck. Ask me questions in person if you need them, and I will see you next time. Have a great rest of your day.